Hello, everybody. This is Christina Crowder from Klezmer Institute, and I'm delighted to welcome you to our third Klezmer Archive Coffee Hour. And in this discussion, we are going to be speaking with Max Rothman, who's going to lead our discussion on the system architecture plan that we developed during our NEH Phase 1 Digital Humanities Advancement Grant work. There's a companion white paper, and we'll provide links here in the chat to the diagrams, and those will also be available on YouTube when this goes up to the web. All right, without further ado, I'm handing it over to Max Rothman, who is one of the, we call as part of the tech team for the Klezmer Archive team, and he's gonna lead us off.
I'm muted. All right, hi everyone, and welcome. That's caught on YouTube in perpetuity. I'm going to share my screen and get this started. One moment. So, all right, got my notes. Okay, so we've got this diagram in the white paper. Right now, this diagram looks really confusing. I promise by the end of this session, everything in this diagram will make sense, and you can hold me to that. So, all right, my goal today, after 2 years of research, we've been working together as a team, and we think we finally have a plan for how to proceed with building the first version of this project we've envisioned. So the goal today is to explain what that plan is and how we made the decisions that we made. I'd love for this to be kind of like an open session, an open forum. So feel free to interrupt me at any time with questions. Put your hand up. I assume Christine will be watching the participant list. Great, thank you. Or just shout. I think it would, if this, if I don't get through all my content and this devolves into a big discussion, I think that would be great. So let's see what happens. So before we get into this diagram, I actually want to start by talking about project goals. Software is capable of really doing just about anything. So the first step in building any piece of software is to take that infinite possibility space and then separate, find the space that you're going to draw, that you're going to carve out inside it, and you're going to separate into two categories: things you're going to do and things you're not going to do. So I'm going to actually start with our goals, the things we're going to do, because they establish some of the fundamental constraints that these decisions were made under. And then when we actually start discussing the plan, then the plan will make sense. So yeah, these goals were established during an early phase of the project through conversations with the team. And I'll just go through them pretty quickly. So we want this tool, the Klezmer Archive, to be comprehensive. We don't want you to have to think about which site is this tune on and how do I find it? No, we are the one-stop shop for everything Klezmer. And if we don't have it, we can tell you where to find it. We want to present information in context. I'm sure, something that's familiar to any of the musicians here are that you've got a case full of lead sheets, charts that have like a tune name, maybe something in the author field, and then the tune. That doesn't tell you where it's from. That doesn't tell you how it relates to other tunes. It's completely out of context. So we want to show that context, not just the context around each item or tune or whatever we're talking about, but also the connections between them. We want to be standardized and curated. We want to be the authoritative source on everything Klezmer. We want people to be able to trust our data. We want people to trust that our data is correct and that it is well curated and that it's telling them correct information. We want to be descriptive, not prescriptive. When we're talking about the history domain and also the musicology domain, there's lots of subjects in which there's conflicting data and conflicting interpretations. We don't want to decide what's correct or not. We want to be archivists and keep track of everything. but then also keep track of the context for each assertion. Who made it? Why'd they make it? What information were they working with? What was their reasoning? And then we present all of that information to users and give them all of the context and the information and let them interpret that. We want this information to be available for research and analysis. So Wikipedia contains a huge wealth of information, but you can't read it with a computer. Not really. It's not structured in a way that makes it easy to read with a computer. And so it's not particularly useful for like large scale data studies. We want our data to be machine readable from the front, so that we think that'll enable new kinds of interesting research, which we can talk about more later. We want all of the tools and all the data and all the processes we build to not just be free as in free beer, but also free as in freedom. So everything is available for other projects to use as they would like to use it. And finally, having all of this data be free and open and available doesn't do anything if nobody can access it in a way that's useful for them. So we want to publish this information in ways that meet the needs of the users that we have. So we could, we have lots of different users and lots of different needs. We want to be available for musicians and researchers and people who are just curious, for experts and for newbies, and also for people who have accessibility needs, be they vision or cognitive or mobility. So this is the set of requirements, basic requirements that we're building under. So next, I'm going to talk about what we're not doing. So these are our non-goals. They're things that are not part of the goals of the project. We don't have any desire to replace existing archives or disrupt the way archives work. We need to survive, to work, to be able to interface with external organizations that have data we want to connect to, or these organizations might be rights holders for data that we want to present. So we're not trying to replace anything. We're not trying to build everything from scratch. We have a small team and very limited funds. If whatever the shortest path is to a result that meets the above stated goals, we will take it. And that means using lots of open source software whenever we can. We're not trying to build a general tool that works for all possible projects. We don't really expect that someone's going to take our entire project off the shelf and then go use it for something else. I mean, they could, but it probably won't do what they want it to do. This is explicitly not a research project. It's a product project. The goal is to produce a working product. That said, if we come across approaches and tools that are useful potentially to other projects, we will absolutely separate those off and make those available. We have a very well-defined scale. This is never going to be as big as Wikipedia, and it shouldn't be. Our focus is on Klezmer, and we don't have any plans to expand beyond that. And of course, that means at the edges of our data, we might link out to things that are not Klezmer, but we'll link out to other organizations or archives or data sources that are more focused on that domain. And finally, we're not going to try to do everything at once. So in terms of media types, we are starting with only the KMDMP, the Kislakov-Makedvetsky Digital Manuscript Project corpus, and only musical manuscripts. Later, we plan to expand to other media types, recordings, pictures, the sky's the limit. But once we feel confident in handling KMDMP and musical manuscripts, so we'll expand slowly as we build confidence in our starting domain. Go ahead, Christina.
I mean, I'd like to just add that we are laying the groundwork for other kinds of media types, right? So we're considering other kinds of media formats in terms of our, our ontology and the way that we're sort of relating terms to each other. But Max is correct that the starting corpus is the KMDMP corpus.
Right. Because we have an intent to grow there, we're kind of leaving unfilled spaces for those things in the designs. We're not shutting doors, but we're also not spending our very limited time and energy on trying to build those areas out. You know, the tech people in the room will probably be familiar with the term MVP. So we're trying to define our MVP. And finally, this set of goals and non-goals results in some interesting technical, I'm gonna call them technical observations. And these observations are going to become, you'll see why they're important later in the presentation, because these are observations we can exploit in the design. The first is, so the curation process means that changes to the data in the system should be relatively rare. I would be shocked if on average we maintained a rate of 1 change per minute. This is actually very, very low in the technical world. Most systems are designed for easily hundreds of changes per minute. And those changes don't have to be made in real time. You think about, the website for your electric utility, right? If you changed a setting in there and then it took a minute for that change to register, you'd be pretty upset. But here, a minute to change a piece of data as it goes through that curation process is totally acceptable. That's something we can absolutely exploit. On the other hand, we expect this data to be viewed very, very frequently. Ideally, I would love if we were up to hundreds or thousands of views per minute. So yeah, this is something that will come up later, and you'll see how we take advantage of that in the design. Next, because we want this to be open and we want to encourage an ecosystem of people who are interested in using this data and researchers who are building projects based on it, if we want to encourage that ecosystem to grow and thrive, we need to have very, very strong backwards compatibility guarantees. If we change the data in ways that break other people's projects, they won't be motivated to work with us. So that means we need to track the changes to the data that we're making over time, and we need to proceed carefully. Once something is in, it's going to be very hard to ever remove in a sort of permanent fashion. And finally, the domain that we're working in, there's a lot of very complicated data modeling that sort of you have to deal with. So just to give a few examples, dealing with dates in the historical domain is really complicated. You might encounter a manuscript that says something happened in spring of 1876, or a few months ago, or when my second child was born, right? So when we're modeling this data, we want to be descriptive. We don't want to sort of interpret those into real dates. We want to capture the sort of the base truth of the assertion that was in the manuscript. But that data model would be very difficult for people to search. We don't want people to have to deal with all that complexity to ask basic questions. So we need to find a way to create consistent interfaces for that complexity. Another one is we've got writing in multiple languages, multiple dialects of the same language, mixed languages in the same text, multiple orthographies. That's all complexity that we want to capture, but also present consistent interfaces for. Same thing for genres in Klezmer. A lot of Klezmer isn't so simple where it's like you look at it and you're like, oh, that's a reel, and you're done, right? There's functional genres, there's performance genres, there's musicological genres, and they overlap and they conflict. So this is the sort of the domain that we're working in, and these are the problems that we have to solve. So with that, those observations about the complex nature of the data we're working with, it became very, very clear from the very beginning of the project that traditional sort of table-shaped relational databases weren't going to work for us. The sort of the property space, the set of properties available for any particular object in the data set, that set of properties is probably very wide, but also very sparse. So you can imagine if you have an Excel spreadsheet, you have to have a column for every single property. That spreadsheet would be 1,000,000 rows wide, but most of the columns would be empty, which is just not a very useful way to approach modeling this data. And then on top of that, we said we wanted to attribute each assertion, and you could do that in a relational database, but it would be a pain in the tuchus. So that wasn't going to work for us. So we very quickly arrived on needing some kind of graph structure, because that seems like a more natural way to model this data. So once we're talking about graph databases, graph data models, graph structures, it was helpful to sort of come up with a short list of properties by which we could evaluate different graph solutions, because there are different models out there. So just very quickly, that I've touched on this already, but the things that we need to be able to attribute citations or attribute assertions. We need to be able to cite, like, why is this connection here? What's the context and the evidence for that assertion? We also encountered an approach called reasoning or inference, which is essentially allows you to define rules that allow you to infer further assertions from your existing assertions. And we think that this is the key for taming that complicated data. So to give you an example of this, the city of, this is straight out of our white paper. So if you've read this, you've seen this already. But the city of Dubno was in the Russian Empire from 1795 to 1918. In the Second Polish Republic until 1939, reoccupied by Russia in late 1939. Then it was in the Ukrainian SSR, and then it's been in independent Ukraine since 1991. So if a tune was collected in Dubno in 1913, what country was that in? We could have a person go through and enter all that data, or we could let the computer figure it out. We would much rather be in the world where we can enter the data once and derive the dependent conclusions from that. I think we think that this will be a way to sort of tame those complicated time and language and writing and genre models. And of course, because the base facts are still there, you can always get down to them if you need to. And finally, we're still playing with this, but we think that the open world assumption is going to be useful for our project. In the closed world assumption, which is the opposite, if you make a search for some piece of data, you get two possible answers back. Either I have it, it's here, or it's not here. So in the open world assumption, you can be told it's here and it's true, it's here and it's false, or it's not here, so I don't know. So in the closed world assumption, you conflate I don't know with no, and the open world assumption separates those. We think that's going to be a useful part of how we model this data and how we sort of describe the world, right? For example, we might not know when an event happened, but we might know that it didn't happen after the person who's involved died. So you can narrow time ranges, you can sort of establish the fuzzy edges of facts. So yeah, these are the things that we are looking for a graph structure to support. So there are two common graph structures and one uncommon one that we examined. This is another page right out of our white paper. You don't have to read this now. I'm going to talk through the important bits. So all right, the first one is, all right, actually, before I get into this, actually, does anybody have any questions? I've just thrown a lot of information at you. Okay, so either everyone totally gets everything that I said so far and is really interested and I should keep going, or everyone is completely lost.
I think you're doing great, Max. I think we're
Great, I'll keep going.
Francis says, no, I don't quite, I'm learning a lot, says Francis.
Okay,
good.
I promise we'll get into some of the non-technical stuff soon. so the first type of graph we looked at are called property graphs. These are popular in tools like if you've ever heard of like Neo4j, that's a property graph. Very briefly, you have so a graph. I should actually say this first. A graph is a data structure where you have nodes and you connect those nodes to edges. And the nodes and edges can represent different things. So for example, the nodes could be people and the edge could be a friendship between them. So that's what Facebook does. Property graphs are great at that sort of thing. You can have nodes and you can have edges and you can connect them and traverse them. And the nodes and edges can have arbitrary data attached to them. So they're really good at modeling connections or networks. But we didn't think that they were very good at modeling knowledge. That data that's attached to the nodes and edges can't itself be referenced by edges. It's sort of opaque. There's also no way to do attribution easily. I've never seen a property graph with reasoning in it, and there's not even a thought about the open world assumption. So that was eliminated pretty quickly. In the library and archives world, the next option, RDF, is a big contender. So I'm going to talk a little bit longer about that one, because RDF is explicitly for knowledge modeling. It's got a huge ecosystem. It's explicitly designed for this sort of thing. And it's used very widely across the world. But as we looked more into it, we started to see shortcomings in using RDF for this particular project. So, for example, there are already RDF tools out there that do reasoning and open world assumption, and there's ways to do attribution. But if you want all of those things integrated together in one package, it's not going to be free and open. And if you want them to be free and open, then you get bits that don't integrate well together. So, for example, your reasoner might infer new facts, but they might not show up in your Sparkle endpoint. Sparkle is like the search interface for RDF, which that doesn't get us very far. That's not very attractive. So also there are, while RDF supports the open world assumption on paper, in practice, we found most people kind of forget about it. Sparkle, the main search interface for RDF, can't produce an I don't know result. It conflates know and I don't know. So that, if the main tool people use to search RDF doesn't understand the open world assumption, then it's clearly not like well integrated into the ecosystem. And finally, for attribution, RDF is a triple store. So everything is sort of in a shape of subject, verb, object. Dogs are mammals. Mammals are animals. So you could infer, dogs are mammals. But, so let's say you want to cite something that, dogs are mammals. To do that, you have to go through a process called reification, where you can't have dogs or mammals anymore. You have to say there's an object called a dog and has a connection to the R, and then that connection. So it creates a very complicated graph structure that makes it very difficult to query. There's another approach called RDF star, but it has limited ecosystem support, so it's not great for this sort of thing. So the last option on here that we discovered through the course of our research is something called first order logic systems, or knowledge engines, or knowledge bases, or there's sort of lots of different names for them. And the interesting thing about it for us is that it expands on the triple store model. So instead of just dogs are mammals, you have a statement consists of a predicate with any number of arguments, and the arguments themselves can be statements. So you could say, is a mammal a dog, or is a dog and a mammal? But you could also have four more arguments if you wanted. And you could wrap that whole thing in another statement that says, because the definition of a mammal is something else. So it's strictly more general than RDF. So that solves attribution right there. Like, check that box, move on. Also, for the math nerds in the room, you might notice that that means that knowledge engines are actually hypergraph engines. So most of these tools also have reasoners built in, well integrated, check that box. Not all of them, in fact, a lot of them don't support the open world assumption, but because you can just throw more arguments in, you just throw like a little true false in that argument list. And now you've got the open world assumption, which is like a testament to how flexible these are and how much you can sort of shape them to fit the problems you're solving. So these are actually very old. It's a very old technology. It's been around since I think the early parts of it were in the 60s and 70s. And they're still used, but mostly by sort of like big iron tech. Like they're used for like drug discovery and logistics optimization. So like very, very expensive packages usually. But there is one of them out there that's open source, but only if you only in single node mode. So you can't have like they can't communicate with each other if you want to have multiple concurrent writes. But that's okay because our write rate is so low, we don't care. So I'll explain what that means in a minute. But anyone who's technical just had a light bulb go off in their head, I hope. So we're investigating type-DB as an option. We actually have a couple other options we're looking at as well. But we can basically take that thing off the shelf and start using it. And so that's where we're heading right now. We're definitely not going to expose, so we want to insulate ourselves to some degree from the tool choice so that we have flexibility to change it in the future. So we're actually going to also build an abstraction layer over it and sort of, build our own way that people interact with this data. But, using these off-the-shelf tools will get us there faster. Let's next, finally, return to our diagram. Now we can start talking about the diagram itself. Before I keep going, does anyone have any questions?
Michael, do you want to sneak in one of your questions before we get into the diagram?
I still feel like I would like to continue with the broad overview because there are so many layers to it. I kind of need to think about where I want to focus. I have like little questions on everything, but
Sure. All right.
Let's just keep going. I think you're doing great.
Great. Okay. So the way to look at this diagram is that there's a big chunk of data in the middle, and then there are ways that people view the data, and there's the ways that people create and change data. So there's writers, data writers, and data readers. They're all organized around this middle data cluster. So I'm actually going to start with the data, because I think once you understand the data, you'll understand, it'll be more clear what these writers and readers are doing, because most of them are like special tuned to write and read certain kinds of data. So as I mentioned before, when we were looking at how we were going to store this data, right? We want to make sure we have backwards compatibility and track our changes, and we don't have any need for a high like write or change or data modification rate. So we're thinking we might actually start with just storing the data in flat files in a GitHub repository. It's kind of like a Google Drive for programmers. That way, all the changes to the data are tracked over time, and that hooks up very nicely with other tools out there for changing data and checking the data is correct and all things like that. And then when we actually want to show the data to people, we'll push it up to either a type-DB server or a set of type-DB servers, and use that as sort of like the write model, or the read model, or like the read cache, or the search index, kind of the way to think about it. So yeah, let's start with the what's in the data store. And I'm actually going to start with the image correlations. So you remember we're starting with manuscript images. So we have these manuscript images. We want to be able to show them to people. We also want to be able to we want to have our data be able to talk about parts of the images. This region of this image contains a tune. Which tune? Let's talk about, what the details about the tune. There's some writing here. Which region of the image is the writing? The tool that we're considering using for this is a specification called Web Annotations. It's published by the same organization that publishes RDF on the World Wide Web. It's an RDF specification, but because these knowledge systems are strictly more general, they can do the same thing. You can sort of do a direct translation. We'll also talk a little bit later, once we're past this sort of data thing, about how we're going to present those images to people and use those correlations. The important thing is we have a chunk of data that's about relating other data to regions of images. We also are going to have manuscript, so text from the manuscripts. So if somebody wrote something down on one of the pages, what did they write down? What are the words they used? What orthography system are they using? What are the multiple translations? Let's have a discussion about what the translations are. Go ahead, Christina.
Can you just move your diagram on the screen, like to zoom out a little bit? Because I think we can't really see from where I'm at. We can't really see the branches that show like the stuff. I know that you're still in that data zone, but
yeah, I just wanted to be able to make sure that people could read the text here, and I'll zoom back out once we're past that. Okay. We've looked at a bunch of different options for modeling the text itself. I haven't found anything very satisfactory. There's a spec out there called TEI, Text Encoding Initiative, which is very comprehensive, but we haven't seen much in the way of tools that that actually use that specification. And so if there's not an ecosystem that we can use to accelerate our work, it doesn't provide much appeal for us. But if anyone knows about tools in that space that might be useful for modeling and presenting that text, please let us know. We'd be very interested. So that one's TBD, but we're working on it. So next, I hinted at this earlier, but a lot of this, like probably a good chunk of this data, is going to be metadata, right? So we have a region of image that represents a tune. That tune has a title. It has, we know when it's collected. It might refer to a town, and that town we want to model about where it is in the world and the history of that town over time. So we've broken up the metadata into 3 groups, which you can read more about in our white paper. But I'm actually not going to go into them now because from a technical perspective, they all kind of work the same way. So it's sort of enough to say.
I'm going to correct you real quick. There's 4. There's 4.
Oh, there's 4. Sorry, right.
Yeah.
My bad. Yeah, there's the 4th one I think is not in here because it's for a later stage of the project, right?
Correct.
Right. But from a technical perspective, pretty much all the metadata works the same way. So I'm going to move on from there for now. But in general, sort of our approach is we're going to use existing ontologies whenever possible to model that data so that we don't have to invent enough of them. We'll have plenty of ontologies to invent because we're modeling things that no one else has tried to invent before or tried to model before. And if we can take it off the shelf, we will. If we can't, we'll try to extend something that exists. And if we can't do that, then we're going to start from scratch. And there'll be plenty of starting from scratch. And the last important piece of data here are the musical notation and the editorial annotations. So, people have done all this great work digitizing these KMDMP tunes. We've got their digitized notation, but we want to be able to connect information to that notation. We want to be able to say, for example, this is the image region that represents this measure of this piece, or somebody was not sure about that note. let's make a note on the musical note. Or this measure is in this key, and then it modulates in this measure. So we want to be able to connect data directly to the notation itself. There are two sort of major approaches for modeling musical notation out there. There are a bunch more that are less widely used, but they're called Music XML and MEI. Music XML is by far the most widespread used. Basically, every music editor, Sibelius, Dorico, Finale, MuseScore, every single one of them has an option for importing and exporting Music XML. But we actually have decided to go for MEI, which is a more academic specification, which also has facilities for describing like editorial annotations, and I think it also does Gregorian chant and a bunch of other things. And the reason for that actually comes down to tooling. It turns out that MEI has a way better web renderer. If you want to render music notation on a web page, the tooling out there for Music XML is terrible. It's basically only good for exporting and importing from like desktop music editors, and rendering music on a web page is kind of a basic requirement for a project. So that made the decision very easy, actually. We're also excited about the possibilities for editorial annotation. You can see there's a box for that I've sort of glossed over, but we're still sort of settling on exactly how we want to model that. But it's a thing that's going to be important for modeling these sort of messy handwritten documents. There are places where notes are smudged, or there's a famous note in one tune that's hidden behind a page fold. There's definitely human interpretation that has to happen, and if we want to be descriptive, we want to be able to model the fact that those interpretations are occurring and who's doing them. But as I said before, we want to be able to connect information directly to this musical notation. MEI and Music XML actually are both XML specifications. So XML is not a graph specification. It's like a plain text format that goes in trees. Tree is but I'm going to have 5 seconds of tech talk for the tech people in the room, and then I'll get back to other stuff. But it turned, we kind of had a realization. We were trying to figure out how to do this. We thought about how do we do this? We could use web annotations again to sort of point to regions of XML files. And we realized, well, XML is a tree, and graphs are strictly more general than trees. So we can do a completely lossless translation. We can do a very mechanical translation from XML to a graph format, and then it's a completely reversible translation. When you reverse it, you lose no information. So that's what we're going to do. We're going to translate the XML into a graph structure, and then we can point to each bit of it directly. As far as we know, this is a novel approach. We did a bunch of research. We couldn't find any other project that figured out how to put their musical notation data directly in their graph. Anyone is aware of a project that does this, we'd love to know about it, because I'd love to talk to them. But yeah, this is one of the more interesting novel results from this project so far. All right, next I'm going to move on to talking about the bigger picture. Before I do that, does anyone have any questions?
Yeah, I was just curious, the last thing you said about translating XML to a graph structure, what do you achieve by doing that?
It means that now that the data is in the graph, the musical notation data is directly in the graph, now you can attach metadata directly to bits of musical notation with a very a low barrier between those types of data. So now, for example, you could use the same tools you're using to search the metadata to search for musical notation. You could present them together, the same, right? Like it all like works together much more tightly that way.
Right. So you're searching through the music, not just, not just turning up whole, like you could search for a musical phrase, for example. Is that what you're getting at?
Well, no, you could even go beyond that. Somebody could ask a question. They could want to know, show me tunes collected from Dubno before 1940 that have this particular musical phrase in them.
Right. Exactly.
And if all that data is tightly integrated together, you don't, if they're not tightly integrated together, you have to first narrow it down. Like you'd have your music search, and then you'd independently have your metadata search, and you'd have to reconcile them. That would be a much slower and more complicated process. If you can do all of those searches in tandem, it'll be faster and it'll be simpler to build.
Thank you.
Anyone else?
Is there an existing tool that does that transformation from XML to graph, or is this something you're going to build?
We're going to build it. And it turns out that it's actually a very straightforward piece of software to write. The knowledge graph specialist on our team, Andrew Parisi, when he came up with this idea, said, "Oh yeah, I've written that piece of software 4 times already." So it turns out this is part of why I was so surprised that no one's come across this idea before. I kind of frankly can't believe that it's novel because it's so simple. But I guess hindsight's 2020.
Yeah, thank you. I mean, it would be interesting, like if there's a specification, like a span of that graph to represent bars or like notation elements of different ways of specifying that.
Yeah, well, that's an area where we're going to do, just for now at least, we're going to do exactly what MEI does. So the translation is going to be very mechanical. It's not going to understand, at least for now, it's probably not going to understand the structure of the XML at all. It's just going to do a direct translation straight into the graph. And I can get into the details of that a little bit more after sort of the main content, if you'd like.
Okay, thank you.
Anyone else?
I just have a quick question about MEI versus Music XML. Is it possible to translate from MEI to Music XML or back?
Yes, but the translation is not lossless. Data information doesn't always translate perfectly cleanly.
Okay.
So, but especially because Music XML is larger, MEI, the MEI ecosystem has tools for doing that because they kind of have to be able to interface with the rest of the world.
Mm-hmm.
But especially if you're sticking to sort of like basic music notation, it's pretty good.
Mm-hmm. Okay, thanks.
Any other questions? All right. So next I'm going to talk about, so we have this data. The next thing we have to do is figure out how we're going to show this data to people. So sitting in text files in a GitHub repository, this data can't really do very much. It's going to be very slow to access. You can't ask interesting questions about it. It's sort of static. So the first thing we have to do is take that data and push it into a format that is fast to access. And that's where we're going to push it into a TypeDB server. And probably actually we're going to push it into is a TypeDB server wrapped in our own translation layer that sort of abstracts out the details of how the data is stored and modeled to sort of present our own consistent model of the information. The easiest, earliest thing we can do is give people raw access to that data. So, for example, let's say you want to download an MEI file. All we have to do is reverse that translation and pop it out. So that's easy. If we want Music XML or PDF, the MEI community has good tools for producing those from MEI files. So we'll sort of pull the MEI file and retranslate it back out of the graph and then do a conversion. For RDF, because, as I said, because the first order logic systems are strictly more general than triple stores, then that means there are things that you can represent in knowledge engines that you can't represent in RDF. So these translations are necessarily going to be lossy. Though our approach for right now is that we want to provide multiple projections of the data. So for example, we could provide all of the data, but without any attributions. Or we could provide all of the data with the attributions, but it's reified, so it's hard to search. Or we could provide, other views. We'll sort of take user feedback and talk about what people want to do with this data and figure out how we want to, what projections would be useful to people. And of course, like the easiest thing we could possibly do would be to provide just a native query interface for our data. So we plan on doing that, and that'll be hopefully we think that'll be useful for researchers, especially people who are willing to sort of learn a new system and interact with the data sort of on its most pure form. For non-technical users, and also everyone who wants to just sort of browse and interact with this data in a more natural way, we are going to have a user interface. It's something sort of Wikipedia-esque, probably, that will generate automatically. That will generate somewhat automatically from the data in the data schema. So, for example, we could design sort of a general tune template, and then we could push data into those pages for each different tune. So today we have the goals for that interface, which are out of scope for the talk today. But in short, we want people to be able to browse around and explore connections and search for things they're looking for, and also to go down a rabbit hole and get lost in the data. And we want it to be friendly and accessible. So that's all things that we're aiming for with that interface. I want to highlight search a little bit here, because the user-friendly interface, the presentation, is really a different technical problem from search. And search is especially complicated for us, partially from a technical perspective, but also from a user interface perspective. This isn't just searching for text on Wikipedia. We have lots of different types of media. We have metadata, we have text, we have music notation, and we'll probably have more in the future. We want to let people combine all of these into single searches that span across all these different media types. So that's actually a subject we're working on in our current grant, is how do we present this? How do we make it usable? How do we technically implement it? So more to come. The final way that people will interact or view this information is, let's say you want to view manuscript pages, or in the future, other kinds of images. These images are often very, very high quality. They're very large images. And so we don't want to just send them all the time to people whenever they want. We want to usually downscale them, and we might want to provide an interface kind of like Google Maps, where you can zoom in and then the quality goes up, and you can zoom out and you can export and all kinds of other things. And there's great tools out there for this already. There's a specification called IIIF, and they have image servers and they have viewers, and they all speak the same protocol. So you just can pick any image server and any viewer, and put them together, and they'll work. So we're actually working right now on adopting what's called the presentation and image APIs. More to come on that actually fairly soon. Any questions before I talk about how we're going to get data into the graph? Great.
Great, Max.
I'm going to move on. All right. So of the processes for getting data into the graph, the most fleshed out right now is the process for musical manuscripts. So all of these processes, they're not strictly software problems to be solved. I would describe them as socio-technical systems. They're a combination of technology and people and tooling to assist people, because this is a curated system. We want the people. Computers can't curate information. You need people to do that. So let's talk about this process. So we've got all of these digitizations of these manuscripts, of the tunes in the manuscripts, that have been freely contributed by volunteers to the KMDMP project, which we are extremely grateful for. But the first thing we're going to have to do with those is curate them, to edit them, right? So we are going to have a curatorial team, and they're going to want to look at those side by side and make sure they're correct. And they might want to add editorial markup. If they were when these volunteers transcribe these tunes, we asked them to leave notes about the decisions they made. But those notes are not structured data. They're just like a text thing on a page on the manuscript page somewhere, or on the transcription page somewhere. So the curatorial team's job is going to be to turn that into structured data, among other things. Go ahead, Christina.
I would add that whether or not the original digitizations were contributed by volunteers, like in any writing or curating process, there will always be an editorial pass over any kind of data that you contribute, particularly notations and manuscript comparisons. So by saying that we'll have this editorial process, it in no way I think there's no implication of sort of demeaning the work that was done by the folks who originally did those notations, because most of them are quite accurate, but it's more to say that any kind of curatorial process will involve an editorial pass. Does that make sense?
Yes, that is 100% correct. All of the different data authoring policies and processes all have curatorial curating built into them. So it is not unique to this particular one. The technical challenge here is, how do we give the curatorial team a tool that allows them to turn those unstructured notes into structured data. So this is an area where we were able to lean on the MEI community. It turns out there's a tool out there called MEI Friend. They describe themselves as a last mile editor. So you wouldn't really want to use MEI Friend to create a new tune, or author a new tune, or to write new notation. But you can move notes up and down, and you can delete notes, and you can, most importantly, it understands MEI like at its core. So it gives you ways to add editorial notations. Also, MEI turns out to have a specification for what they call facsimiles. So where you can have you can attach bits of notation to regions of images, which is something we need. So the idea is that we're going to use MEI Friend to allow the curatorial team to structure that information. Now, you might remember that we didn't want to use MEI for MEI facsimiles for image correlations. We wanted to use web annotations. But that's okay. That's this is where the tools are. We don't want, and it would take us so much more time to build a new tool. So our approach right now is that we're going to sort of allow MEI Friend to produce for us a quote unquote fat MEI file, a packed MEI file with lots of extra data in it. And then later in the process, we'll pull that data out and translate it and put it into the appropriate places and structures that we want in our knowledge graph. And then when we export it, we can always reverse those translations and like reproduce a fat MEI. So after that, we can use GitHub again, right? So the editorial team member can make a pull request, and there can be technical checks on the correctness of what they produced, and they can have other members of the team review their work. When everyone agrees that it's in the shape they want it to, they can what's called merge the pull request. They can approve that change, and then a technical process can automatically pull apart that MEI file and then insert it into the right parts of the knowledge graph. So the next area I'm going to talk about is metadata and text. And I'm actually going to talk about them together because they're both in progress. So in the end, these will probably look similar, right? There will be a way, like a user-friendly interface by which the curatorial team can author and edit data, and then it'll go through a set of review steps. There'll be technical and human checks, and then it will merge into the knowledge system. So text, as I said before, is a bit of a challenge because unfortunately we haven't found any equivalent project to MEI friend. There's no TEI friend, unfortunately, as far as we've found. So if anyone knows of tools in this space, we'd love to hear more about them. One tool we have been using very successfully is called coda.io, which, if you're familiar with the note-taking app Notion, is essentially if Notion had a baby with a spreadsheet. Christina's been doing an incredible amount of work there. The important thing is that it allows you to structure your data and do formulas, and data can reference other data. And the other thing that's important about it is that it's really easy to get it to sync with other stuff. So we're starting out kind of playing around in Coda, and then eventually we'll figure out how to get the data out and then put it in the knowledge graph. And it might be that Coda ends up being one of the solutions for the user interface, quote unquote, for this stuff for a while. Go ahead, Christina.
This is a little bit of a snarky comment, but based on my colleague Clara's experience, I think Notion isn't the best comparison for Coda. I think a more better comparison, excuse me, that's bad English, would be Airtable with Docs combined.
Yeah, that's a good one.
Yeah, and all of the data, they do use a relational database, but they're still flat. They're still basically flat tables that interconnect with each other. So they're not graph shaped, as far as I understand.
Right. It also helps that the data that we're dealing with right now is sort of that basic, what we call group 1 metadata for the most part, which is the least graphy of the metadata that we're going to have. So it's the most table shaped. I suspect at one point, eventually we'll probably grow beyond what Coda can do for us, but it's a great tool for right now.
It's more than, I mean, we're doing genre and typology, so
That's group
it's
2.
not good for that. I mean, it's better than Google Sheets. It's way, I mean, it's way better than Google Sheets. But it's hard to discriminate in search when you have things bunched into different columns. But we are exploring that part of the program and running into lots of really interesting problems with that. So that genre and typology plus just basic core factual information is where we're at with Coda right now.
Right. Yeah, and one general theme for this diagram is that I would say in general, the right half of the diagram is more long-term, and the left half of the diagram is more these are processes that we're building for the problems that we have right now. And over time, we expect these processes to evolve as our problems evolve. But hopefully along the way, we're building tools and learning things that make building those future processes easier. So I've now gone through the whole picture, the whole diagram. So every box here should now mostly make sense. So I think now we could transition into Q&A or discussion, or if people have thoughts, or however we want, where we're going to go from here.
You know what I would love to hear, and I'm not the only person here, but what I would love to hear is, can we get a sense of what is currently built and in use?
Sure.
Or is this all vision at this point?
Max,
It's
do you
not.
want to unshare for a sec so we can all see each other for a hot minute, and then we'll go back into the diagram as we.
Sure. So what's been built today? We're currently in the prototyping stage. So we've the thing that's going to arrive soonest, probably, is a way of accessing manuscript images, that IIIF stuff. And we also think, yeah, go ahead. I think we're going to also get some of the metadata that go with those pretty soon. That's going to come out of Coda.
Yeah, I think the next thing that's going to happen is that we're going to be able to like share the Coda database in a view form, but that's searchable. Like the Coda has a way of like there's like a search there. You can add a bar that allows for searches on certain columns, so people will be able to search for KMDMP numbers. They'll be able to search by genre typology. They'll be able to search by social function. You know, like I've been adding as a sort of an editorial process, like a core certain genre and typology information that will change. And there's a certain amount of things where you can do intersectional searches. Like, you know, you want to know how many Skochnas did Motel Raider have, right? You know, and or how many mazurkas are there in the whole corpus? Dan Karkner has also made some subgroups of certain kinds of tunes, like you have the Durmdicke Stickelach, Southern tunes, long form compositions as subgroups. So hopefully that will be able to project that out, that people will be able to play with, and it will be, and it also combines for the first time, actually, if you're familiar with the KMDMP project, we had the catalog worksheet and the Heft Mac worksheet, and these were two separate places. So if you were thinking about one tune and you wanted to see what information there was about a tune that was in the Kisselhoff that was described in the catalog, you had to actually look in two different Google Sheets to find that data. And now we figured out a way to like unify the records. I've created a whole new, hopefully will be invisible global ID system that allows us to merge those data together, but while still preserving the independence of the sheets where they come from, because they describe different things. So and then the hope is very soon, I'll just finish this real quick, is attached to that Coda view, you will also be able to click on a link to get the PDF. So you're thinking about a tune, you find a tune, you're like, oh my gosh, it's a Lancers Quadrille, I'm so excited about this, that you'll be able to just click the link to get the PDF file will come up that you can then.
And you should go to the click link and view the manuscript image that is, you know, in an appropriate quality for web viewing, you can deep zoom into.
Right. So that's
maybe look at the next page and look at the previous page and, you know, scroll around in the images.
Right. So that's kind of like that's kind of our broad hope, is that we'll be able to sort of show that as like, it's really like the 2.0 version of interacting with Kisselhoff data, I think. Yeah. Right?
The important thing about this is it's not throwaway work, and it's not just for KMDMP. The process of doing this is is like, this is coming out of or going through doing this. We're also cleaning our data, and we're getting familiar with the data in ways that allow us to start to understand how to model it for the next stage. So this is sort of a general principle of the project, is that we want to be producing regular results as we sort of, you know, like each next target should produce a useful result for the community, while also getting us one step closer to our final goal. So we've also done some other things. We have a lot of prototypes that are, I would describe as not fit for general consumption. We've done a music search prototype. We have some very early prototypes in we've played around with like the graph structures and knowledge system and stuff like that. And we have some sort of early ontology ideas, ontology prototypes for describing data. Yeah, we're definitely in the learn as much as you can, as quickly as you can stage.
We're also going to do some prototype playing around with like some really basic data viz stuff that we can use as part of a user experience, sort of like things like Max and other tech people in the room may be a little bit bored by this, but we came across a thing. It's like Ferber, which is FRBOO, is kind of a data whiz-bang data thingamajig. It's a data model. And we came across some Ferber data viz stuff at one of our retreats, and Clara and Eleanor and I were like, ooh, super cool. So we're gonna like, because it's really fun to be able to sort of see data in different shapes and different visual ways. And so we're going to try to take some of the things that we've been working on conceptually about how to connect tunes together and how to link items together, people, recordings, items, and stuff, and see if we can play with those really basic Ferber viz, data viz things to see if there's things that we like, things that people find useful, right? Because like having something be neat isn't necessarily useful. So we want things that are both neat and useful. And so we're going to use these really simple, kind of a little bit off the shelf things that kind of already exist to sort of be in touch with people in our community to say like, do you find this interesting and useful? You know, should we continue on, you know, working further with these basic ideas before we invest a huge amount of time into like really designing or building anything? Does that make sense? And do you agree with that, Max?
Yeah.
Okay.
I think one day we'll have like holographic displays to interact with the music and video. But I have some questions I'm just going to paste in chat whenever you're up to them.
Sure, I'll go through these. Can the digitizer's text notes be extracted from the music XML? Kind of. One of the drawbacks of music XML is that the music XML produced by each music editor is a little bit different. And so when you're looking for text, you have to find out, you have to know, like, is that text a text box? Is it a field? Or is it like a lyric that they just pasted it into? In the end, it doesn't really matter for us, because the most important thing for us is that it's not that we want to structure the comment itself. So we want to structure the information contained in the comment, right? That comment says something like, in measure 3, the note is ambiguous whether it's a C or a D, and I think it's a C because of the mode, right? That's actually, like, that sentence, separate from how it's in the music XML, is the thing that we want to structure. Because there's a way, in, for example, in MEI, you can say, you know, you can model and structure, and so you can say, you know, there's two options for this note, and we think this is the probable one, but this one also could be an interpretation. So this is going to require human interaction regardless, which is why I'm describing this as a socio-technical process.
Okay, but could you just extract all the text into a file and give it to the curator?
You could. They're going to want to view it in context, though.
It's actually easier. I mean, honestly, having now sort of done some of this work, it's actually really almost easier to either copy paste certain items into another space, or like I'd almost rather work from the PDF because I can copy paste some information, but there's other things that are like, as we're discovering with the scholarly editions work, that there are some kinds of things that almost have like we're going to be developing codes systems that are used on if you have a player's, let's say you have a player's folio that you're putting together for the violin Machiavelli pieces that are for, like, maybe they're going to be kind of some of these longer form pieces that Daniel has worked on. On those pages, there's like apparently this is common in the classical music world, that there's like a system of symbols that are used to indicate that a note is ambiguous, or that some other kind of piece of information. We're just starting on this process, so I can't name other examples. And so as we sort of develop that sort of symbolic system and kind of group things into particular kinds of categories, we might also end up with some kind of there's going to be a way that those concepts like interact with the MEI. MEI already has a way to define those things, but we may also discover our own language that sort of standardizes these concepts across all the multiple people who have made notations of these things.
Okay.
And so to conclude that thought, like, one of the greatest values of having all of our contributors like really become editors and to be close readers and to make those notes is to assist the editors to know, oh, I need to make sure that I look very closely at that note or that region. And so there's like a dialogue between myself or one of my co-editors. There's a dialogue between your notation, Eric, that you contributed, and me as I'm reinterpreting it and putting it into MEI to say, oh, I see that Eric wrote that this was an ambiguous note. I better go look at that and make sure that I don't do that human thing of just glossing over, right? So the careful attention that our contributors have added will be a tremendous help to us as we reinterpret the data, but I think more so on that human to human level than like something that might be glossed by a machine importation of that data per se, right? Does that make sense?
Yeah, I'd say if you can get something that's helpful where they could just cut and paste the text somewhere else,
Totally.
that's good.
Yeah.
And then,
it's very.
Mhm.
It continues to be very handmade. Like this.
Yeah,
this,
I understand.
You know, this data, we're actually quite lucky in a way that we ended up with this really super messy data set.
Mhm.
It is so messy, and it's so gloriously messy and so human that we need to really create systems that are robust enough to be able to handle all of this deep complexity. And so that when we get to something as simple as a CD, you know, it'll just be like, oh yeah, we can suck in data from all kinds of different places that's already it was already created in a digital space, right? So it's a blessing and a curse as I sit there on my, so many hours, cleaning and cursing a little bit, but you step back and you're like, I'm so grateful that this is what we're able to do,
Yeah, thank you.
Sure.
So my next question is about the high contrast images, because sometimes there are things I saw in there that looked erased, and I made notes about that.
So that's something we're definitely thinking about for that IIIF presentation of the image. There are a bunch of IIIF editors or IIIF viewers that have allow the user to select between different image filters, like black and white or high contrast. And some of them even have sliders, so you can tweak them as you want. So I'm actively, when we're selecting a viewer, we're actively looking for those features because we think they'll be helpful for curators and transcribers and everyone else. So that's definitely something that's factoring in our decision making.
Yeah, maybe Bob Blacksburg could talk about how he made those.
Right, exactly. Yeah, one of the things I've thought about is I wonder if we could. This is like an idle thought. I have no idea if this is supported, but I wonder if we could, have the sliders accessible, but then also have a set of presets.
Okay.
I don't know if that's currently technically possible with the viewers without making any code modifications, but it would be really cool if it was, and it's something we'll definitely keep in mind as well.
Yeah, put it on the product backlog.
Right, exactly. It's in the product.
Okay, cool.
Your next question was, can digitizers and curators have personal blogs in the system to document their processes and reasoning, later links from decisions to blogs? I think we'll have to talk more about this as we figure out how we want to model the curatorial data. We definitely want to capture directly in the system why people made the decisions they made. That's actually one of the reasons that it's so important for us to have that musical notification directly in the graph, because a curator or an editor or anyone could have some text and then connect that directly to a note, a stem, a measure, a portion of a measure, a portion of multiple measures, a region of an image, right? They can connect it to anything and attach a note to it. And ideally, I think we want to actually have them attach the conclusion to it and then have their note be the justification for that conclusion. And then that way, that's the context, right? That's the attribution of the citation is, Eric Rangel said, I did it this way because I did it, and that's why I did it.
Yeah, it's really the second part of my question where I'm thinking of blog, like documenting human relationships and like my Klezmer story. I was in New York in 2005. I saw this band. I saw them play this. Yeah.
Yeah, so that could take the form of something that's much more familiar, right? The Wikipedia citations.
Yeah, I was just thinking within this system we're building, if you had like a standard blog interface that people could use and see each other's blogs. Yeah.
Yeah, that's an interesting idea. We've also, I shouldn't really be saying this, but we've also idly thought about like messaging or forum capabilities, allow people to talk to each other. That's very TBD. That's very far out. It's not anywhere near.
So what I'm thinking about is blogs where I have my private, then these I'll share, and these I'll send for curation, and yeah.
So, yeah, it's definitely something we could look at as we build. We'll have to. I'd be interested to learn more about that, what you have in mind offline.
Yeah, sure.
So I'll add to that concept. I want to sort of maybe turn the prism around a little bit, so a slightly different view, which is to say that with the archive as it's conceived right now, the individual melody is the sort of is the core unit of archival thing, right? So if you, for example, have an observation, if let's say I'm an editor and you're a contributor, let's just set this up as this little story that we're telling right now. So I'm the editor and I've made a notation in the MEI that says that this is in Hannah Skoczna, the third note in the B part is partly hidden by a thing, but there's a thing that says that it might be ambiguous. Is it an E flat? It's E. And I actually decide to say that it's either, and it's Schrodinger's Skoczna, and we won't know until we go to Vernadsky, right? So, but anyway, so that aside, we all know that one example, or hopefully people will learn more about that example. But I, as the editor, I attach that note inside of the MEI, right? And now you can come along, and you will come along, and you can say, and this is where we have the commentary and discussion is one of our really core ideas that we have about this thing. So that rather than you having a personal blog per se, and you can do that too, but let's set that aside. When you come in and you can say, when I look at this, I believe that note is an E natural, and your comment attaches to that item. And then in our sort of commentary and discussion view around, this is what we call the Talmudic view of this piece of music. We might have a little incipit of the tune in the middle, or a little image of the tune in the middle, and then all of these comments can go around the side. So your comment then attaches to the item, right? Now, rather than having it be separated into a blog where you might discuss, now in your own personal blog or you're in a blog space, you might talk about a number of different tunes where you're mentioning, something from the Radarhest and a Hershkovitz thing and another thing, and then you are talking about them in together. But hopefully then, in each of those items, the fact that you've mentioned those items will link out to those, because we're in this graph space. If there's a tag that you can say, O2 or 0237 1024 or whatever, like that flags it, that your comment goes to that item as well.
Yeah, as long as I could link out to it.
Right. It's a little bit flipping the idea on the side that, so the idea of the personal space that can be your collection. We have talked about that, but we for sure kind of conceptually right from the very beginning are like having this idea that the commentary contributed by people who view the items will all be sort of aggregated around that thing. And so Daniel might come in and say, well, I played with some friends, we played this tune in the park in an outdoor jam, and we had so much fun, and people came over and they had a really great time, which, so we have like all kinds of different kinds of commentary can attach to the item, right? And one can be very deeply musicological, and one can be experiential, and one can be musicological, but we have that ability to surround the item with this sort of robust discussion.
Yeah, what I'm saying is, we'll put a note and link out to see the context within my story.
Sure.
Right.
Yeah.
Yep.
Yeah, actually something I'd be really interested to track once sort of this whole thing's established is look at ways to track the way conversations about this data are happening outside of the database itself. So to, for example, connect to every Facebook comment that mentions a tune. And also in the real world, look at who, maybe allow people to mark which tunes that they play, and then track when they actually play it. Maybe we have like a jam app, right, where you can hit shuffle, and with all the tunes you can take all the tunes you can say who else is the jam. We'll find the intersection of all the tunes that you hit shuffle, and it shows you the tune, and then we track who played it.
Yeah, once you get the data structure right, you could go wild with it. Yep.
Exactly. That is the core idea, is if we structure everything, if it's well structured and it's all available and it's in one place, then the possibilities are endless. So like my elevator pitch for the Klezmer Archive Project is, what if we put all of the information that everyone knows about Klezmer in one place and made it readable by computers? What would then be possible?
Yeah, you could do AI, maybe joining them together somehow.
Yeah, right. Or what if we trained machine learning models to identify what regions tunes are from, or identify significant like similarities. Maybe we can find all the tunes that share like musical motifs and track them through space and time. Like there's so many possibilities.
Yep.
Step one,
show me all
in one place and get it modeled.
Yeah, an example, show me all the arguments of people who said it's a B natural and who said it's a B flat.
Exactly. You got it.
Cool.
All right, your last question, integration of the data from the current Google Sheets and Facebook discussions. The Google Sheets are actually currently in progress. That's what Christina's working on, at least in some degree. So that hopefully we'll start seeing bits of that become public soon. The Facebook discussions, we would love to get back to those at some point. That's going to be probably group 2, 3, and 4 metadata. So that's a little bit ahead of where we are right now. And unfortunately, I think that process is going to have to be extremely manual.
Yeah, if there's just a way to extract it all out of Facebook and then go through,
there's
I don't know.
Really.
No,
because they have a whole data privacy. Honestly,
yeah,
I kind of suspect that what we're gonna like one of the reasons that I keep thinking about way far in the future some kind of chat function is because I'd love to get those discussions off of Facebook.
Oh, definitely. Yeah.
There's a whole future discussion about how do we we can't tell people please move your discussions, right? We have to make this an attractive place for the Klezmer community, and that actually points to another sort of possible future function of this project is as like sort of a community center for the Klezmer world.
Yep.
When will we get there?
You get Facebook without all the other crud. Just the
Exactly, right.
Yeah.
When will we get there? Notice I said when.
Yeah.
Not soon.
I know.
But it's definitely, we're thinking about a lot of different things that could be interesting to do in the future. But right now you see that architecture diagram is very focused on like just getting the data set together.
Yeah.
Trying to get enough mass in one place that you can sort of catalog, you can have that critical mass that sparks the fission or fusion or whatever, and everything goes boom.
Yeah, this discussion was very helpful in giving it context, putting all the pieces together in my mind. So thank you.
Mm-hmm. Cool.
Daniel, you've been very quiet this whole time. Do you have any observations or questions or thoughts, or
have you put
I
on the
do.
spot?
I have a couple. So first of all, just the very last thing you were talking about, is there any interest in Activity Pub? Like, do you know about that one?
Yes, I'm aware of Activity Pub. It could be interesting. Honestly, we haven't even gotten as far as thinking about like how we might begin to think about implementing that. It's way ahead of where we are.
Yeah, for sure. In general, like about the Klezmer Archive stuff, I sometimes think it's like, that proverb about the elephant in the night, where you're like, so different people are feeling different parts and they're describing it. That's how I still feel about this. I'm like, I think I know what you guys are talking about, and then I'm like, wait, they said this completely different thing. So I'm like, oh, okay, revising my conception. And I'm just wondering, do you have, obviously, like, you're very sort of agnostic about what the final platform or whatever would look like. Do you sort of have a general conception, or even you're not even there where you're thinking, oh, it's going to kind of look like this type of website and these components will interact in these ways, or you're truly building some kind of architecture and not even thinking at that level yet?
So I think one of the interesting things about it is that it will look different depending on how you want to interact with it. So for example, if you want data export, so you want to interact, you want an RDF API, we'll provide that. That's an interface that will be available. If you want to browse around and poke at things and search for stuff, then there will be Michael Mendelssohn's back. I admitted him. There will be a web interface that I think earlier I described it as Wikipedia-esque, and
I'm sorry.
I'm not gonna.
No, please. I'm sorry. You cannot associate that word. It is no. Wikipedia is ugly. It is not going to be ugly.
Not in terms of how it looks. How in terms of the kinds of functionality it has, right?
And also, I'm sorry. You cannot.
We want to do better,
word.
obviously.
You cannot use that word.
The idea is there's going to be like a web page. You can imagine like a tune having a web page that has the image from the manuscript on it, and next to it has the transcription, and then might have notes about those things around it, and might have metadata like around or above, or and it might have context, and you can sort of imagine sort of putting all the kinds of data you'd want to know about that tune on that page. If it's a person, you can imagine having either a short biography or some basic information about them. But so you have different sort of shapes of pages for different topics, for different kinds of data, and having information that's appropriate to those types of those sort of templates, those data types on that page. And they might have links to each other, and you might be able to browse around and find things that are interesting to you about them. I think one of the design goals for this interface is to we really like the concept of the Wikipedia rabbit hole. People get lost for hours clicking links on Wikipedia. So that's
please stop using that word.
Well, I'm not saying we're going to build Wikipedia. Like that's that's the thing people do on Wikipedia, and that we want people to have the same kind of rabbit hole experience on the thing we build. So that's like something we're thinking about as we design it. But yeah, part of what's complex about it is there's going to be different interfaces. That's going to be one possible interface, but there'll be other interfaces too.
Can
So
Related to, oh, sorry.
Oh, I want to just step in one more time. So I just dropped this. I know, Michael. So and there's not, aside from the ugliness factor of Wikipedia, like the other thing that like we've had as a very core discussion is that when you look at a Wikipedia page, if you don't look under the hood, what you see is a single narrative, right? The story is a single narrative, and it's edited behind the scenes. And one of the things that we think is a core value is like, and this sort of discussion and commentary is that discussion and contradictory opinions is visible, that we're not collapsing our story about an item into a single narrative. So that's part of my really strong reaction against it. And aside from the graphic interface, which is super useful, but like also like not a huge amount of delight, is that it's very important for us to like be exposing the disagreements that we all love. And without sort of valuing, well, my opinion wins. That somebody else's opinion has to win. We want those opinions to exist side by side, and let people, in a very Talmudic, philosophical approach, say, well, I see, and on the other hand, so like this, as we do in our discussions, and then I think you can also imagine that about an item, you might have like a very data heavy view that might have like kind of look like an Omeka, like the Omeka classic kind of Omeka. What do they call those things? They're gallery, like museum. It's like a museum artifact thing that gives you the factual data. And so like this, you might have a musicology sort of view that sort of like an early vision. I don't know if this will end up happening, but an early vision was that you would have like the manuscript image on the top. Maybe you would have what do they call that stuff? A web rendering of the music in the middle, and you might have a pitch graph down below. We've seen these kinds of applications in some other kinds of projects where you kind of really just looking at the music and the musicology as a view, like that you could switch between. And then there might be a view that is like this sort of commentary and discussion view that would sort of present different kinds of information. So are they all on the same one page? I don't know. Are they different views of the same data? But like, these are the kinds of discussions that we're having. And I will mention that this link that I just dropped in the chat is the VM Rebetico website. Is something that somebody just turned us onto, and maybe you know this site already, but in terms of sort of delight and rabbit holing, that website is kind of one of the most compelling that we've found that also is kind of in our domain. So, hello.
Yeah, and then the last thing I want to say on this topic is that cat is adorable. The last thing I'll say on this topic, you've definitely kicked the wasp's nest here, is I want to actually flip that question back at you, right? So we're going to have the data, and we're going to be talking to you and people like you to find out how what presentation of it is useful to you. So one of our core principles is that we're not building this for ourselves. I mean, we are building it for ourselves. We're also building it for everyone else. And the only way to figure out how to do that is to talk to people all the time throughout the project. That's part of why we're not being very specific about the appearance or the structure or what kinds of data will be there or not. It's because we don't know yet. We haven't talked to enough people to know what they're going to want on it. And we want it, first and foremost, we want it to be useful to them, right? There's no point in building it if it's just, for me.
Right. Though that is, I will say that like, as we're kind of gearing up, as we're really ramping up into our first, this first part of our phase 2 grant, like actually we have a kind of a preliminary, like throw darts at the wall, sort of like, what do it look like discussion, like really on the books, so that we can just sort of get a sense of like all of our dreams, our hopes and dreams within our team, and then kind of see what that looks like. And then we'll start doing user research, particularly around this idea as we start showing the coda, which how, I don't know if you've been back there recently, but Daniel, but it's the changes have happened, right? But as we start showing the CODA data and letting people fool around with the filters and stuff like that, that we can be talking to folks as they start interacting with that and seeing what they like, what they don't like, what we can serve up through that platform, and what we need to do to get to be able to serve the things that people really want to have. So yeah. So Daniel, we'll have we're doing, in fact, speaking of, we're doing an internal CODA demo soon, and maybe, and I just feel like very soon in the future, like before Yiddish New York, we'll have some public CODA demos that you're of course invited to, and that we'll invite people into. And of course, Daniel, you can go snooping around in there yourself.
Any other questions?
Just back to the different views. I just remembering the one you showed last year at some point that was kind of branching little. There'd be a block of text and then it's linked. You had some early demo where you're showing the concepts linked. So is that more of just behind the scenes thing that you were thinking of at first, or is there still any notion of having one of those sort of branching graphical representation of the link between, a tune and Michael Alpert and Branya Sakinen? That's what you had in some kind of early thing.
That's a
Totally.
visualization we could absolutely have. That's one of those things, is once you have the data, making visualizations of it is relatively straightforward. I think, the criteria that we will apply to all of these is, what do people want to use it for, and is it good for that? So, like a lot of projects we've come across in our research, they're like, oh, well, look, I made a pretty picture. And it's like, okay, what's it good for? How do people use it? And they're like, I made a pretty picture. So, we want to, again, constantly check things against how users are using them. So, again, I'm being non-specific because we haven't talked to enough people to know what it's good for yet. But yes, all visualizations, this is, back to the first thing I said in this whole thing was, you want to take the space of infinite possibility and carve out, what are we doing? What are we not doing? And we have the goals, but we don't know enough to have the implementation for those things yet.
Yeah.
The primary criterion we're using for carving up that possibility space is, what do people want to do with it?
But this dream lives on. Where's Brandfine from? Where's Brandfine's family from? Do you happen to know this off the top of your head, Daniel? Or can you look it up and then we can the article that you wrote?
Don't make me pronounce that Polish place name. I've never heard it said aloud.
Right, but so
the Klezmer Archive will have a pronunciation, so you'll be fine.
Okay, great. But if we can when we're able to just do this really basic thing of being able to take a location, let's just say Dubno, just because we talk about Dubno, let's say, or Kremenets, and we're able to stack onto it all of the the Hershkovitz, I can't remember. Okay, so we've got multiple. Let's just say Dubno. Let's just say we've got all the multi-rater tunes that they're in a little circle around Dubno at this time period, right? And then if we're able to link back things that we know from a later period, also stack them on top of Dubno, then you just in a very seamless way you can see, oh, is there a connection? What is the linkage between those things? And hitherto we just haven't had the ability to do this. These are not unknown technologies. Obviously the technology to do this it's known and easy. It's just that we haven't been able to do it with our stuff. And I think this is where it becomes really particularly useful for transnational musics. We're doing klezmer, but if you're thinking about other kinds of diaspora musics, being able to say, oh, this performer that's known in North America is from this place in some other place, and then also be able to layer on the known instances of music or culture from that original place in a sort of a fast and easy way, then visualize it, because we're visual people. We like to see things like this. Then we can start to have those analytical connections, in a way that's more seamless, you know?
One of my like pet dreams for this project is that you can search for a musical motif, and the search results could show you locations, but also time. And like you didn't even create this visualization to show motifs moving from place to place over time, but it's going to show that to you just as a result of the search that you made. And suddenly you see the path as it moves throughout wherever it moved. And maybe we actually have data on, oh, and this person brought it to the US. And then, then it went on to this, 78. And then it was discovered by Deborah Strauss, and then she played it and then taught it at this festival. And then all these people learned it and they recorded on their album. So you can trace the full history of a tune or a motif or an idea throughout time and just like follow all the breadcrumbs. And that'd be so cool.
This Rembetico website has this really nifty view where if you do a search, you see all of the things as tiles, like whatever your results are, you can see them as tiles. You can see them as a list. And then the third option is to see them in this sort of nifty timeline bucket system where it allows you to have, there's like musical pieces, postcards, images, sound recordings, yada, 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 but they're like grouped according to their time. And it gives you this sort of vertical stack of all these things. And then as you hover over a button, it will tell you what is the record that's being referenced. And, that for me is just pure delight. In addition to the knowledge that's there, there's just so much delight in being like, ooh, oh, check it out. Like in the same year, this postcard shows this image of a bridge in Brooklyn. And in the same year was a recording of a song that's about, immigrating and living in Brooklyn for the first time, whatever the thing is. Like, I don't know what I do with that piece of information, but the fact that it's able to be served up so easily is really awesome. And there's a lot of meaning, I think, to be sort of gandered together as we look at these things. So,
Eric, I wanted to take your comment and flip it back at you. Thanks for dropping your email in there, but I also encourage you to get on our mailing lists if you're not already, and follow our blog, which we haven't posted much on recently, but we're hoping to actually put some real content on there soon.
Yeah, I've been in contact with Clara, so whenever.
Great. Awesome. Yeah, well, we have those channels for posting information, and we can we'll definitely be sort of continuing to share information there as we continue to develop this.
Okay.
Yeah, we're a little behind on blog posts this week.
Very behind on blog posts.
Right. But I think we're hoping to sort of push some of that stuff out the door pretty soon.
Yeah.
So,
any other questions or anything else before we call it a day?
Thank you so much for hanging in for the whole session, both of you. Like, we're really super amazing.
Thanks
I
for
just
the
wanted to ask
explanation.
one thing. The programming languages that you'll primarily be working in?
No idea.
No idea yet. Okay.
It's going to depend. This is one of those things where we're going to follow the tooling. So, for example, for musical analysis, there's a great package called Music 21 in Python. So we'll be using Python for those. The graph stuff, it turns out, I don't know where we're going to go with that yet, but like my pet choice would probably be Clojure, because Clojure is really good for open data structures.
Yeah, I read that about Clojure. That's what I was interested in.
Yeah. Actually, one of the alternative, am I going to say this on the recording? Sure, why not?
You want me to?
One of the alternative ideas we've had for if, we're looking at, TypeDB and a few other options. And one of the few other options is we can sort of soup up one of the Clojure triple store databases, Datomic or DataHike or Data11 or DataScript, because they're very popular in that ecosystem. We can take one and sort of soup it up into a knowledge system. We'll see which one ends up emerging as the victor. But
if you can't do everything in the tool, write your own tool.
Right. It is one of those things where we're, small project, limited time and funds, so we have to
Yeah,
take the
I get it.
path. So we have to really follow the tooling, whatever. And
Sure.
it takes being like having a very global view, right? Like you're finding the shortest path, but you have to do that without exploring the path first.
Mm.
So it's a tricky problem. That's why
Yeah,
part of why
you don't have a Gartner magic quadrant right, for this.
Correct.
Right. Okay.
Right, exactly. Yeah.
Got it.
So yeah, that's one of the things we spend a lot of R&D time on, is we don't have time to like churn on ideas. So we have to design and research and find out where the most productive angles will be first as best we can, so that we don't waste our very valuable developer time on them.
Sounds good. Thank you.
Alrighty then. I want to thank Max. Like, I don't know how to say thank you enough for like leading us through this incredible discussion. Like, it's really amazing to see all of that work like that went into this very sort of dry and dusty white paper, and like this staggering amount of research that went into creating that diagram, like have a voice and being like just talked through and discussed, and helping us springboard into this a little bit more show and telly sort of phase of our project, because we're prototyping and testing. So we're going to be quite a lot more engaged, I hope, with our audiences of many varieties as we start tinkering and building and showing things. So that's great. So thank you all for coming. Thank you for sticking around to the end. And we're looking forward to seeing you all again soon.
Yeah.